Okay, we want to look at how to use S.P.D.F notation in calculating or in drawing electronic configuration of an element. So the first thing we need to know is the procedure on how the step or how they are being produced. So I will try my best to make this. So this is how we arrange it and how we make it. Now, the first you need to know that is that what you just do, you just write 1x, 2x, 3x, 4x, 5x, 6x, 7x. So if you have done that, then you come to this place because it is S.P.D.F. So you come to this place and start with 2p, 3p, 4p, 5p, and 6p. So you stop there. So you see I left one up, left one down. You stop there. Then you come to D and you start with 3D, 4D, and 5D. You stop there. Then you come to the F. Then you start with here 4F. You can make it 5F, and the case may be. Then when you start drawing, you make sure your arrow go like this. So your arrow will always go like this, as you can see. Then you can see the arrow goes like this. 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 Then the next one, the arrow goes like this. So if you are arranging it, it's going to be from the arrow that you just arranged. You have 1x, comma. The next one is what? 2x, comma. The next one, look at it. After 2s, the next thing is what? 2p. So this line is 2p before this because it goes like the 2p. We have 2p. Then what? 3x, comma. after 3x, you come to this. We have 3p. After 3p, the next one is what? 4x, comma. After 4x, the next one is what? 3d. After 3d, the next one is what? 4p. After 4p, the next one is what? 5x. Okay. After 5x, the next one is what? After 5x, the next one is what? 4d. After 4d, the next one is what? 5p. After 5p, the next one is what? 6x. After 6x, the next one is what? 4f. 4f. After 4f, the next one is what? 5d. The next one is what? 6p. The next one is what? 7s. Now this is how we draw it. This is how we draw it. So this is the pattern that follows. So that means if you are drawing for any electronic configuration, it's going to start from 1s, 2s, 2p, 3s, 4p. Okay, so for the first 20 elements, I think they stop here. I think the first 20 elements, okay, this is 2, 2, this is 6, this is 2, this is 6. Okay, the first 20 elements stop somewhere, stop here. So we are going to be considering this regarding the first 20 elements. Since we are just starting, they stop. That's where they stop, the first 20 elements. But this is how they are being arranged. Now, one thing you should also note that again is that S can carry a maximum of 2 electrons. Then P can carry a maximum of 6 electrons. Then D can carry maximum of 10 electrons. Then F can carry a maximum of 14 electrons. So these are the electrons that it can carry. So if I am to draw for electronic configuration using S.P.D.F notation, if I have a question now, they said caption, which is 20, I'm asked to draw the electronic configuration of caption using S.P.D.F notation. What I need to do is to write, don't forget I said S carry maximum of what? 2 electrons. So it's not be what? 1x2, comma, the next one is what? 2x, 2s2, comma, next one is what? P can carry maximum of 6 electron, that's 2p6. Next one is what? 3s2. Then the next one is what? 3p6. Oh, I think it's mother. 2, 2, 2, 2, 2, 2, 6. That's 2, 2. That's 10, 6. Okay. The last one is what? 4x2. So the first 20 elements stop somewhere here. Stop here. So let's count if it's correct. We have 2 plus 2, 4, plus 6, 10, plus 2, 12, plus 6, 18, plus these 2. So you see that to draw caption, we have it in this pattern. Then what we did yesterday, we also did for potassium. Potassium is 19. Potassium is 19. So if I'm drawing for potassium that is 19, it will be what? 1x2, 2x, 2x2, 2p6, 3x2, 3p6, 4s1, 4s1. So that's for 19. Now we also did for sodium. Sodium is sodium is 11. So if I'm drawing for 11, so what will I do? I will do, that is what? This will be what? 1s2, comma, 2s2, comma, 2p6, comma, 3x1. So you look at it now. 2 plus 2, 4. 4 plus 6, that's 10, 11. Now, I told you that the reason why S.P.D.F notation is far better than KNM share that I taught you yesterday, that they answer 3 things. Now, there are 3 things that S.P.D.F notation answer. Number 1, it answers the block of elements. It answers the block of elements. Number 2, it answers the period of elements. Then 3, it answers the group of elements. So the reason why S.P.D.F is more preferable to KLM share, it answers these 3 questions. For example, if I have a question now, let's take example 1. We are asked, calcium belongs to dash group and dash period and dash block. So if you have this question, calcium belongs to dash group, dash period, and dash. So all I need to do is I'll just come with a solution. I'll just write, since I know calcium is 20, I'll just do the S.P.D.F notation. I'll do that's 1x2, 2x2, 2p6, 3x2, 3p6, 4s2. So this calcium, look at it. 2 plus 2, 4, 4 plus 6, 10, plus 2, 12, plus 6, 18, plus 2, 20. So we have 20 already. So I will not, so to answer the question now, so I'll come to the last number. So what number is at the top is my group. So that means since it's 2 here, that means calcium belongs to what? Group 2. The period, I'll come to the what is standing with the letter is my period. It belongs to period 4. Then the block, it belongs to block X. I see it down. Period group 2, period 4, and block S. So this is why S.P.D.F notation is far better than our KLM share. Now again, there's one thing. There's another trick here again. When the electronic configuration end in P, you cannot determine the period, the group, and the block just the way I did for calcium. For example, if we are considering this element now, let's consider this element that stopped at 3sp. So let's say element X is what? Is 18. Element 8 is 18. So element 8 is 18. So let's say element 8 is 18. We want to draw for it the first S2sp, 2s2, sorry, 2s2, 2p6, 3x2, then 3p6. Now since this is 18, 2 plus 2 4, 4 plus 2 10, then 2 plus this 8. So this is 18 already. This is 18 already. Now I want to know what is the group, what is the period, and what is the block of this element. Now to know the group, the period, and the block of this element, please don't come and say the period is the group is what 6, because I said in this one the group here is 2. If it end at x, if your electronic configuration stop at s, then you can say the group is 2, the period is 4, and the block is x. But when it stopped at p, please, the group is this and this. What is standing close to the last number? You'll not be considering the previous number and the last number together. Do you get it now? That means the group now of element s, element x is equals to 2 and 6. That's what group. That's group 8. Then the period is 3, and the block and the block is what? P. This is how we differentiate both of them. That will differentiate both of them from one another. Hope this is clear. If you have any question, just drop your question.